Hello everyone, this is Adam the Paleo-Nerd, and yes, I did indeed decide to change my YouTube name from Adam Raptor to Adam the Paleo-Nerd. Anyhow, today we'll be looking at one of our ancient relatives, a fellow synapsid that lived during the Permian period known as Dimetrodon. Before I begin, however, I would like to say that I will be leaving a bibliography containing all of my sources at the end of the video and in the video description below, due to my sources taking up a large amount of space in the video description. In addition, I will put the first pieces of my sources, such as the author or the title, for both the information and the pictures on the screen as I discuss them and as they appear throughout the video. Those can be used as a guide to direct you towards each of my sources at the end of the video, as I will have them all listed in alphabetical order. So please stick around until the end if you would like to see the full list of my sources. Anyway, let's get to the actual video. To start with, the genus known as Dimetrodon was first discovered in the 1870s by the American paleontologist Edward Drinker Cope while he was exploring a group of rocks known as the Red Beds in Texas. He had originally labeled the first Dimetrodon specimen under the species name Clepsydrops lambatus. Sometime around the year 1877, after some sphenacodontid remains he had previously discovered in the state of Illinois. Although Cope first described this sailback synapsid with the genus name Dimetrodon in the scientific journal called Proceedings of the American Philosophical Society about a year later, in the year 1878. Now, where and when exactly did Dimetrodon live? Well, these early synapsids are known to have lived in what is today Europe and North America, although to be more specific, the fossilized remains of Dimetrodon in Europe have only been unearthed in Germany, while in North America, fossilized Dimetrodon footprints have been found in Nova Scotia, Canada, and the skeletal remains have been unearthed in New Mexico, Oklahoma, and Texas in the United States. Dimetrodon remains have been dated back to the Sakmarian, Artinskian, and the Kongurian ages of the early Permian, or more specifically, from approximately 295 to 272 million years ago. In any case, as depicted in the global maps of the Earth shown here, there were only two major landmasses on the planet during this point in the Earth's history. These two landmasses included the still-forming supercontinent of Pangaea, the largest landmass on the map, and the smaller continent of Siberia, just to the northeast of the supercontinent. Both the supercontinent of Pangaea and the continent of Siberia were surrounded by the superocean known as Panthalassa, and the two smaller oceans known as the Tethys and Paleotethys, which the superocean Panthalassa would one day become the Pacific Ocean. The Paleotethys Ocean was located in between the continent of Siberia to the north and the Cimmerian terrain to the south, which a terrain is essentially a fragment of continental crust which broke off from one tectonic plate and later became accreted to a continent on a different plate. While the Tethys Ocean existed in between the Cimmerian terrain to the north and the southern section of Pangaea, known as Gondwana, to the south. Anyways, contrary to popular belief, the genus, known as Dimetrodon, is actually a member of the clade known as Synapsida, or stem mammals. Synapsids are a clade of amniotic vertebrates, which can be distinguished from other amniotes by their characteristic trait of having only a single pair of temporal fenestra, which are located in between the squamosal, postorbital, and jugular bones of the skull, which temporal fenestra are large openings that are found in pairs on either side of an amniote's skull, the purpose of which is typically to store large and powerful muscle groups in and around the animal's skull, such as the jaw muscles. A comparison between the different amniote skulls can be seen in the sketch I did, which is shown here. Additionally, being an amniote essentially means that a vertebrate animal can either lay their eggs on dry land without having to live near water, or they can retain the fertilized egg within the mother while the embryo is still developing. Furthermore, Dimetrodon is also a member of a specific family of synapsids called Sphenacodontia, which are a group generally characterized by large carnivorous synapsids, which existed from the late Carboniferous to the middle of the Permian. Therefore, Dimetrodon was not a dinosaur at all, so please stop calling them dinosaurs. Anyways, I digress. The actual genus of Dimetrodon is actually a very large one, with at least 13 different verified species of Dimetrodon discovered thus far, which all vary in their size and shape. I will get around to explaining this a little more in a little bit. In any case, the areas in which these early synapsids lived are now thought to have been largely covered by extensive wetland environments during that point in the Permian period. This would pretty much be the exact opposite of the desert environment depicted in the BBC's documentary series from the year 2005 entitled Walking with Monsters. At least in the area of the supercontinent, which would one day become the continent of North America, Dimetrodon shared its wetland habitat with a variety of different animals, which included insects, fish, such as the 3-foot-long freshwater shark, Xenocanthus, amphibians, like the Diplocaulus, reptiles, such as the Catorhinus, and other synapsids, such as Edaphosaurus and Ophiachodon. The larger species of Dimetrodon most likely would have filled the apex predator niche in their ecosystem, while the smaller species may have filled in the other niches in their wetland ecosystem. Why is it that I always end up doing videos on predatory animals on this channel? In any case, Dimetrodons ranged in size from the small, cat-sized Dimetrodon teutonus at around 60 centimeters or around 23.62 inches in length, to the giant Dimetrodon angelensis at around 4.6 meters, or about 15.09 feet in length. Yet a majority of the Dimetrodon species range in size from approximately 1.7 meters, or about 5.58 feet, to about 4.6 meters, or 15.09 feet in length. Also, it has been estimated that most of them weighed anywhere between 28 kilograms or 61.73 pounds and 250 kilograms or about 551.16 pounds. As described by the Virtual Fossil Museum's website, one of the more famous species, known as Dimetrodon grandis, grew to about 3.05 meters or about 10 feet in length, and probably would have weighed in excess of 181.44 kilograms or about 400 pounds. So now it's time for me to tell you all some fun facts about Dimetrodon. The name Dimetrodon means two measures tooth, due to them having two different types of teeth in their jaws. According to the website called newdinosaurs.com, the first category of teeth would have been used to catch and hold prey, while the second type of teeth would have been used to tear off chunks of flesh which the animal would then consume. This also means that Dimetrodon was a heterodont, as it possessed more than a single tooth morphology. Even though one could consider Dimetrodon to be an ancestor of us mammals, it is very likely that these animals did not have fur covering their bodies. The reasoning as to why we think this stems from a scientific report which was published in the year 2015 by Piotr Bajdek et al., where it is described that a piece of coprolite, or fossilized dung, from the late Permian was found to contain hair or hair-like structures within it. These hair-like structures could have been from a synapsid that lived during that time. However, those researchers also conveyed how this is also the oldest piece of evidence we currently have for hair being on early synapsids. This unfortunately means that Dimetrodon most likely did not have hair covering their bodies, since the late Permian would still be after these sailback stem mammals went extinct. Instead, these animals most likely would have either had smooth skin, similar to that shown by the skin impressions left behind by a synapsid from the Middle Permian called Estamenosuchus, or they could have had scales, similar to the ones found on another synapsid from the early Permian called Ascendanenus. Now let us discuss the ears of this animal, or rather the lack thereof, since Dimetrodon did not really have any external ears to speak of. Instead, Dimetrodon likely would have had internal ears, or possibly some other method of detecting the vibrations caused by sound waves. External ears would still have yet to develop when the bones that make up the middle ear start developing in the later and more advanced ancestors of mammals and in mammals themselves. At least according to the paleontologist and paleoartist Scott Hartman, who I have mentioned previously on this channel, Dimetrodon likely used a walking and running posture known as the high walk, which is the semi-sprawled gait that we can occasionally see in extant or living crocodiles. Hartman goes on to explain that we know this because we have discovered trackways within the past few decades which are thought to have been made either by Dimetrodon or by another closely related synapsid, indicating that these animals most likely would have walked with a more upright posture and with their belly and tails held well above the ground. I think it would also be worth mentioning that the skeletal drawing of Dimetrodon by Scott Hartman at the same source that I got this information is the same skeletal drawing that I use to help me draw this Dimetrodon shown here. Anyways, as everyone is probably already aware, Dimetrodon had an enormous sail protruding from the animal's back. This dorsal sail-like structure, which extended down the length of the animal's back, was made from the extremely tall neural spines which jutted upward from the animal's vertebra, and was probably held together by soft tissues such as skin, blood vessels, and muscles. In addition, Dimetrodon's sail may have been used to assist in regulating the animal's body temperature by forcing the warm blood from the body's center into the blood vessels which ran throughout the sail to have the blood cool off before it re-enters the body's core. Although this tall structure jutting out of the synapsid's back may have also been used for display purposes. I should probably point out that these uses for the sail of Dimetrodon would be very similar to those of the much later and completely unrelated theropod dinosaur known as Spinosaurus from the late Cretaceous period. Nevertheless, a scientific study was conducted in the year 2012 by Elizabeth Rega et al. On the morphology and function of Dimetrodon's iconic sail. During their research, the team observed that some of the neural spines had been fractured and then later healed at some point while the animal was still alive, which indicates that there had to have been some sort of connective tissues in order to keep the bone in place as it healed. Although Rega and her team also noted that the tops of these spines were often bent and misshaped, sometimes even at extreme angles due to injuries which the animal had sustained in its life. This piece of evidence which the team had uncovered would suggest that the tips of these spines were more exposed than the lower parts of the neural spines, which would have been more connected by the soft tissues. Well, unfortunately, that is all I have in my notes for the animal known as Dimetrodon. So to wrap up this video, Dimetrodon was a genus of predatory stem mammals that had a gigantic sail jutting up from their backs and are known to have lived in the wetlands of what is today the continents of North America and Europe during the early Permian period. This also just goes to show that you should not just assume that a now extinct animal is always a dinosaur just because of its age or its general appearance. In any case, before I go, I would like to give a quick shout out to my good friend and colleague, Pete, for helping me find some of the information that I need in order to make all of my videos. Also, for my next video, we'll be going back to talking about non-avian dinosaurs by discussing one of the earliest dinosaurs we currently know of, called Herrerasaurus. Anyways, I will see all of you in my next video. Bye!